The intensity on the screen at a certain point in a double slit interference pattern is 64% of the maximum value. What minimum phase difference between sources produces this result? B. Express the phase difference as a path difference for 486.1 nanometers. Let's pull out the information. This 64% of the maximum, I'm gonna write as intensity at a certain point equals 0.64 I naught, because I naught is our I maximum. We want to find out what is the minimum phase difference, which is, we normally denote it as a phi, that produces this result. So let's recall our expression for intensity at any point of the interference pattern. I would suggest you to review my video on intensity of the interference pattern before you watch the solution of this problem. So going back to our expression, at any point intensity in the pattern equals I naught cosine phi over 2. Of course, squared here. So it seems that from here we can completely find the phi by dividing both sides of this equation by I naught. So we will have cosine square phi over 2 equals I over I naught. And plug in our I is 0.64 I naught over I naught. I naught will cancel out. We'll end up having cosine square phi over 2 equals 0.64. Now let's take a square root from both sides. We'll have a cosine phi over 2 equals square root of 0.64. And then finally, we can find the phi equals 2 times cosine inverse of square root of 0.64. Plugging this into our calculator, make sure that it is in radians, so we will get 1.29 radians. So that's the answer to the first question. For the second part, to express the phase difference as a path difference, we know that pretty much we know that the path difference delta R is related to phi. And we are looking for delta R now for that particular wavelength lambda equals 486.1 nanometers. Okay, so let's try to analyze this. Delta R, the path difference is directly proportional to the phase. So if the path if the phase is 2 pi, then the path difference, the phase difference is 2 pi, then the path difference is lambda. I can make a ratio from here. Phi over 2 pi equals delta R over lambda. From here, I can find lambda equals 2 pi over phi times delta R. Or rather, we need to find the delta R. So delta R equals phi over 2 pi times lambda. Now we can plug in the numbers, but make sure that we do everything in radians. So we found phi is 1.29 radians divided by 2 pi radians times our wavelength 4.80. Oops. in a wrong spot. So times 4.86.1 nanometers, and punch this into our calculator, we will get 99.6 nanometers. That would be our corresponding path length that corresponds to the 1.29 radian phase difference. Thanks for watching. Stay tuned for more to come.